Okay, good afternoon to everybody. Okay, the date for today is January 4, 2024 and the time is 2 p.m. Okay, my topic for this afternoon will be a random topic and this falls under the so-called study of DC circuit. This is especially good for those who are planning to take up electrical engineering. So this is for you guys. Okay, let's proceed. My subject matter for this afternoon will be DC circuit, and the title of the subject matter will be, this is a random topic, Superposition Theorem on the so-called computation of current under DC circuit. So this falls under DC circuit, Superposition Theorem. Okay. This problem was the same from the previous random topic. For this discussion, I will be presenting another solution from that previous random topic. So supposed to be, we will be bringing out the same answer as from the previous discussion. Actually, the total current is 2.726 amperes. I think the previous discussion, the total current is 2.726 amperes. So for this afternoon, I will be presenting superposition solution, and supposed to be, the answer will be the same. Okay, let's proceed. The circuit diagram will be the same, even the values are the same. So we are given two voltage sources, 12 and 18. This is 0.4 ohm, this is 0.2, and this is 5 ohm. The problem is just asking what will be the current passing through the 5 ohm load due to this 12 volts and due to this 18 volts. For this solution here, I am sure that if we try to short this one, the current delivered by the 12 volt source on the 5 ohm load will be in the downward direction. And if we try to short out the 12 volt source, for sure the current coming out from the 18 volt passing through this 5 ohm load will still be downward. Okay, so by using the superposition, we will try to solve for the first current due to this and the second current due to the 18 volt source, and to compute for the total current passing through here. Okay, since they are in the same direction, we will add it. Okay, let's try to bring out the solution. If we try to bring out the solution under the so-called superposition theorem, if there are two voltage sources, to compute for the current delivered by the first voltage source, we must have to short out the second one. So consider the 12 volt source, we short the 18 volt source. So if we short out this one, this will be the resulting diagram. Okay, 12 volt, this is 0.2, 0.4. We short out the 18 volt source, so no more 18 volt source here. But we took into consideration the 0.4 ohm resistance, and this is the 5 ohm load. Okay, to compute for the total current delivered by this 12 volt source on this 5 ohm, we must have to compute first the single equivalent resistance of this. And I refer that one as I total with the subscript number 1. Okay, let's try to formulate the equation on how to compute for this one. The total resistance will be 0.2 ohm plus the single equivalent of this. And I designated the single equivalent of this to be RE1, meaning equivalent resistance with the subscript 1, meaning due to the 12 volt source. Since these two here are in parallel, to compute for RE1, it should be, okay, parallel resistance is concept. It should be 1 over RE1 should be equal to 1 over 5 plus 1 over 0.4. That's the concept on how to compute for the total resistance if they are connected in parallel. And if we try to simplify or compute for RE1, RE1 will be the product of 5 times 0.4 over 5 plus 0.4. This one here, we are adding two fractions with different denominator. So the numerator will be 1 times 0.4 will be 0.4, 5 times 1 will be 5, and the resulting denominator will be the product. This is 5 times 0.4. Okay, that's the simplification of this. So if we compute for RE1, okay, RE1 now will be 5 times 0.4 over 5 plus 0.4. And what will come out will be 0.3704 ohms. So the symbol equivalent of this will be 0.3704 ohms. Okay, so after taking the symbol equivalent will now be in series with this. So the total resistance will be 0.2 plus the symbol equivalent, which is 0.3704. And the computation of this is this. So total resistance with the subscript 1, meaning due to the 12 volt source, will be 0.2 plus 0.3704, and the total resistance will be 0.5704 ohms. So it seems we are now given a 12 volt source here, and the total resistance is 0.5704 ohms. And this is 12 volts. So actually we could compute now for the total current. This is now the single equivalent of this RE1 plus this 2. So using the equation voltage equal to IR, therefore current now will be voltage over R. Okay, so this should be 12 volts over 0.5704, and the total current delivered by the 12 volt source is 21.039 amperes. What's next? The resulting diagram will be like this. Right? If we try to compute for the current passing or the voltage across this, it should be 12 volts minus the voltage drop here. So I place it here, the voltage across RE1, okay? Or this is across the 5 ohm, across the, it should be 12 volts minus the voltage drop here. And the voltage drop here will be the current passing here. The current passing through the point 2 is 21.039 times 0.2. So this should be 12 minus 4.2708. So the voltage across the load, across this, will be 7.792 volts. So if we know the voltage across this, and we know its resistance, therefore we could compute for the current passing here due to the 12 volt source. So I with the subscript 5 ohm, number 1, equal to the voltage across it over 5, and this is 1.558 amperes. It is downward. Okay? Oh, you got that one? The voltage across this should be 12 volts minus the voltage drop here. Okay? Let's try to consider the 18 volt source. If we try to consider the 18 volt source, we short out the 12 volt. So the resulting figure will be this. 18 volts, 0.4, 0.2, this 5 ohm. No more 12 volts because we short it out. And to compute for the total current delivered by this 18 volt source, we must have to take first the single equivalent of this one. And we designate that one as RE2 equal to. Okay? And that will be 1 over 5 plus 1 over 0.2. Or that is 1 over RE2. Okay? To compute for the total resistance, we take the single equivalent of this. They are in parallel. So RE2 will be 1 over RE2 will be 1 over 5 plus 1 over 0.2. Okay? And if we try to simplify this one, it's the same as the first one. But the values will be different. So this will now be 5 times 0.2 over 5 plus 0.2, or what will come out will be 0.923 ohms. So the single equivalent of this one will be 0.1923 ohms. The single equivalent. So the total resistance of the circuit now, when the 12 volt source is shorted, it will be 0.4 plus the single equivalent of this. And as per our computation, it is 0.1923. So it will become 0.5923 ohms. So it seems we are now given a voltage source here. And the single equivalent resistance, this is 0.5923. The total single equivalent, and this is 18 volts. So if this is 18 volts and this is 0.5923 ohms, we could compute for the current it will be delivered by this. So voltage equal to IR, therefore current will be voltage over R. So this is voltage over R. And the current delivered by the 18 volt source will be 30.39 amperes. Okay, what will be next? I will draw a circuit diagram again. This is 0.4, right? This is 0.4 ohm. And this is 18 volts. And the voltage here is actually the voltage across the 5 ohm. Okay, we could compute for this. The voltage across the load now will be 18 minus the voltage drop here. The voltage drop here will be the current passing, which is 30.39 times 0.4. So I place it here, the voltage across the 5 ohm load, okay, will be 18 volts minus the voltage drop here, right? So it will be 18 volts minus the current passing is 30.39 times 0.4. This is still voltage equal to IR, right? Current, this is resistance. This is voltage. So what will come out will be 5.844 volts. Meaning to say, if we try to short out the 12 volt, the voltage across this, due to this 18 volt source, will be 5.844 volts. So if we know that the voltage across this is 5.844, the current now will be the voltage computed divided by its resistance. This is voltage all over resistance. So the current passing through the 5 ohm load with the subscript 2, meaning delivered by the 18 volt source, should be 1.169 amperes. And this is still downward. So this is 1.169. The first one is 1.558, right? Due to this 12 volts, the current passing here is 1.558. Due to the 18 volts, the current is 1.169 amperes. So the total current passing through this 5 ohm load due to this 12 volt and 18 volt will be the sum of 1.558 plus 1.169. So I place it here. Since they are both downward, we take the addition. 1.558 plus 1.169. The total current passing through the 5 ohm load due to the 12 volt and 18 volt, total, it will be 2.726 amperes. I think this was the answer from the previous random topic with the same problem. The current is 2.726 amperes. Okay, that's it, guys. That's how we compute the total current passing here due to this 12 volt source and 18 volt source by using the so-called superposition theorem. Okay, for those of you who would like to subscribe to my channel or watch my videos on my channel is at youtube.com/@ProfDavidJTLS. If you want to share it, please click share. Okay, good afternoon from Los Angeles.